Welcome to today's video, where we'll be exploring the universe and its origins, taking you on a fascinating journey through space and time. We'll discuss the birth of the universe, the formation of galaxies, and the various elements that make up our cosmos. So sit back, relax, and join us as we unravel the mysteries of our cosmic home. The Big Bang Theory. Our understanding of the universe's origin starts with the widely accepted Big Bang Theory. Approximately 13.8 billion years ago, an unimaginably hot, dense point, called a singularity, suddenly began to expand, marking the birth of our universe. In the first few moments after the Big Bang, the universe underwent rapid expansion and cooling, allowing for the formation of subatomic particles, followed by atoms. Over time, these atoms came together to form stars, galaxies, and eventually, the vast cosmic web we see today. Cosmic microwave background, CMB radiation, the afterglow of the Big Bang, is the oldest light in the universe and provides evidence for this theory. Formation of galaxies. As the universe expanded and cooled, gravity began to pull clouds of hydrogen and helium together. Over millions of years, these clouds formed into the first stars, which then gathered into groups called galaxies. Through the process of merging and interaction, these early galaxies eventually grew into the variety of spiral, elliptical, and irregular shapes we observe today. The Milky Way, our home galaxy, is a barred spiral galaxy that contains hundreds of billions of stars, along with gas, dust, and dark matter. The cosmic web and large-scale structure. The distribution of galaxies throughout the universe is not random. Instead, they are organized into a vast cosmic web. This interconnected network of galaxies, separated by vast voids, is shaped by the gravitational influence of dark matter. Dark matter, which makes up about 27% of the universe's total mass energy, is an invisible and mysterious substance that only interacts with other matter through gravity. Superclusters, enormous collections of galaxy clusters and groups, are the largest structures in the universe, stretching across hundreds of millions of light years. The future of the universe. Our universe is not static. It continues to evolve and expand. Current evidence suggests that the universe's expansion is accelerating, driven by a mysterious force called dark energy. There are several theories about the ultimate fate of our universe. One possibility is the Big Freeze, or heat death, in which the universe cools and becomes too diffuse to support any kind of life or structure. Alternatively, the Big Crunch scenario posits that the expansion of the universe might eventually reverse, causing all matter to collapse back into a singularity. The study of the universe's origins and future is an ongoing and ever-evolving field of research, with new discoveries and insights constantly emerging. The role of cosmic inflation. In the early moments after the Big Bang, a brief but crucial phase called cosmic inflation is believed to have occurred. During this period, the universe expanded at an exponentially faster rate than it does today, smoothing out any initial irregularities. Cosmic inflation helps to explain the uniformity of the cosmic microwave background radiation and the large-scale structure of the universe. It also provides a possible origin for the seeds of cosmic structure, as quantum fluctuations during inflation could have been stretched out to astronomical scales. The formation of the first stars and galaxies. The first stars, known as population 3 stars, were composed primarily of hydrogen and helium, as heavier elements had not yet been created through nucleosynthesis. These stars were massive, hot, and short-lived, producing the first heavy elements in their cores through nuclear fusion. As these early stars reached the end of their lives and exploded in supernovae, they enriched the surrounding gas with heavier elements, enabling the formation of the next generation of stars and the first galaxies. The first galaxies were likely small and irregular, gradually merging over time to create the larger, more structured galaxies we see today. The role of supermassive black holes. Many galaxies, including our own Milky Way, are believed to harbor supermassive black holes at their centers. These black holes are millions to billions of times more massive than our Sun and play a crucial role in galaxy formation and evolution. The intense gravitational pull of supermassive black holes can influence the orbits of nearby stars and help to stabilize galactic nuclei. Additionally, they can drive powerful jets of energy and matter into intergalactic space, affecting the rate of star formation and the growth of galaxies. The epoch of reionization. After the formation of the first atoms, the universe entered a period known as the cosmic dark ages, during which it was filled with a neutral gas of hydrogen and helium. This gas absorbed most of the radiation emitted by the first stars and galaxies, rendering the universe opaque. As more stars and galaxies formed, their ultraviolet radiation ionized the neutral gas, stripping electrons from atoms and creating a plasma. This process, known as reionization, made the universe transparent to light once again and marked the end of the cosmic dark ages. The multiverse theory. While our understanding of the universe has grown significantly, there is still much that remains unknown. One intriguing idea is the multiverse theory, which suggests that our universe is just one of many in a vast, possibly infinite collection of universes. The multiverse concept arises from certain interpretations of quantum mechanics and string theory, as well as the idea of cosmic inflation. Some theories propose that different regions of space could experience different rates of inflation, giving rise to a multitude of bubble universes with distinct properties. While the multiverse theory is still speculative and unproven, it raises fascinating questions about the nature of reality and our place in the cosmos. Dark energy and the accelerating universe. Dark energy is a mysterious form of energy that makes up approximately 68% of the total mass energy content of the universe. It is believed to be responsible for the observed acceleration of the universe's expansion. The nature of dark energy remains one of the biggest unsolved mysteries in modern physics. Several theories have been proposed to explain it, including the cosmological constant, quintessence, and modifications to the theory of gravity. Understanding dark energy is crucial. It makes up approximately 68% of the total mass energy content of the universe. It is believed to be responsible for the observed acceleration